Hello and welcome. I'll be taking you to the findings of Project 2, where we were building machine learning models of clustering and classification using banking data sets. Banking industry is one of the earliest sectors to use predictive analytics to support their customers, and there is still more potential of using advanced analytics in this sector. Currently, the sector is experiencing challenges, especially in the era of online banking, where fraud has been rampant, and we will try to address this by building data-driven approach to help in classifying and helping and predicting fraud. We realize in this sector there was more reliance on rule-based methods which are no longer helping. On the same note, we will be trying, there is a continuous need of monitoring customers, and we will be classifying their customers to enable them understand better, and in essence improve their monitoring. The methods we will deploy in clustering, we deploy k-means to cluster using various features like account balance, transaction amount, post-transaction balance, credit metrics, customer engagement, and credit utilization. And majorly, we will use the elbow method to determine the optimal clusters. This k-means was chosen for its simplicity and ability to scale it in a large data set. We will also employ random forest classifier for classification, and our classifier will have 100 n estimators with a maximum depth of 5. We adapted the random forest because of its robustness in dealing with no messy data. Key insights from our exploratory data analysis: our data set 1,000 rows and 40 variables, and we realized dates majorly were in object, and we standardized them to date to time. And majorly the processing involved in clustering, we will scale our dataset using standard scaler, and for classification we will split our datasets in true, train, and test, the ratio of 80 to 20. In addition, in feature engineering, we added two variables, that is a credit utilization score, utilization ratio, which will help us as a risk indicator. We also added customer engagement score, which was a weighted matrix to enable us determine the value, to gauge the value of customers. And from exploratory data analysis, we realized our data was significantly imbalanced with few cases of anomaly. And we also noted there is moderate negative correlation between credit utilization and credit limit. We also noted positive correlations between credit utilization ratio and credit card balances and minimum payment. Other indicators had weak correlation. Uh, our random forest classifier was evaluated using average precision, and it had a performance of 94%. This was significant because of the nature of the imbalance, and average precision of 92 simply indicate that our model was able to correctly classify anomaly with high precision uh, among different recall levels. And it was important because it helps us in distinguishing, it has a robust capability of distinguishing anomaly between different thresholds, or what we can simply say among recall levels. Our findings on clustering, we were able to correctly classify customers into 4 clusters, where cluster 0 was composed of high-risk creditors with high credit utilization ratios. Then our cluster 1, which majorly components were they majorly presented customers which were disengaged, and cluster 2 represented customers which are highly active with moderate risk. Then cluster 4 represented customers who were fairly stable, financially stable, and notable features, they were financially stable, and they were not into taking of credits. And this one will be helpful in determining how we can monitor and develop targeted approach of engaging with these customers. Like cluster 0 with risk was prudent that they might be helped to various strategy of education so that they can maintain their risk within tolerable levels. We also noted like cluster 3, which are financially stable. These are ideal for engaging and enlightening them with more opportunities where they can develop wealth management strategy by preparing products for wealth management so that they can be targeted approach in this cluster. And our random forest classifier, despite having high average precision, it performed poorly. It had high false positives and low true positives. This can be attributed to the fact that the high class imbalance, we did not get enough significant features that can enable us to distinguish between anomaly and normal transactions, and therefore it is imperative that it is necessary that integrated we should integrate domain knowledge so that we may be able to understand normality and actually enable our model to be trained, learn more features that can enable them to distinguish and predict anomality. In regard to features importance, the most critical features that was important in this case was interest rate, which was followed by minimum payment due and credit utilization ratio. On ethical consideration, due to the fact that our that data set was highly influenced, there was high chance that it could introduce bias and through it could introduce bias that can disadvantage a segment of population. And it was also noted that our segmentation, there was chances that it can also create unfairness where certain category may be given preferential treatments. And in all this, transparency was key, whereby it is we communicated our model limitations such that this may enable and promote accountability on the user and on traceability. We used clear visual with enhanced with descriptive tests that the stakeholders is able to follow and understand. Thank you.